Thank you, everybody, for joining. I'm super excited to talk to you. As we said earlier, my name is Chris Waldon, and I am a site reliability engineer at IBM as my day job. However, this has absolutely nothing to do with my employer, and don't think otherwise. Now that we have done that, I want to talk to you about something that's been bothering me for a long time. I think that the way we do chat is a little bit broken. The paradigm doesn't fit as well as we think it does. And I think that the experience of instant messaging everywhere kind of suffers as a result. And so I want to show you some examples of what I mean. So if we have a group of coworkers who are trying to plan a birthday party, one of them asks, hey, what are we going to do for so-and-so? And then two coworkers respond. And they respond with two different ideas, and they respond at approximately the same time. Someone else says, yeah, I love that idea, but it's ambiguous which idea they're talking about, right? When Jordan composed their message, we have no idea whether only Jennifer's message was visible or whether Shamil and Jennifer's were visible, or whether Shamil's came in right as Jordan hit send. You can't tell. And so you have to do a follow-up here. And that doesn't seem like much, except that this structure recurs everywhere within chat. Someone will post an interesting link, and people will respond with their opinions about that subject, and then people will respond to those responses, except all of that gets interleaved, and I might want to talk about a thing that is 4 messages above me. So my best option is to try to quote it, and that's a fair amount of manual work that is really tedious, and I think we can do better. But also threads. I don't know how many of you have to use a enterprise chat platform, but Mattermost and Slack, and I imagine some of the other players in that space, have adopted these, anonymous ad hoc channels that you can spawn off of some message in order to have a sub conversation. And the idea, I think, was that channels get pretty noisy, and you want to be able to take some specific conversation about some specific subject matter and kind of move it out of the way of the majority of the people participating, the people who may not care about that subject. But all of the implementations of this that I've seen have a really horrible discoverability problem. The threaded content kind of disappears into an ether from which it can only be summoned if you have participated in the thread. So, someone might ask a question, and there's a threaded conversation trying to help them get their answers. And the question didn't seem especially interesting or relevant to you. So you don't participate. So you never know that 20 responses in, the subject matter kind of shifted and it became interesting to you. You never find out. There's also a weird, tool literacy problem on these platforms where new users don't really know about or understand threading. And so they might not think to use it. And then the power users of whatever platform are angry because now the conversation's occurring in 2 places. Now there's people talking in the thread and there's people talking in the channel. And it's very difficult to bring those 2 things together in a way that's coherent. But also, I think that in the 21st century, one of the universal human experiences is being part of a group message. And that might be text message, that might be WhatsApp, I don't know, I'm trying to think of the platforms that, you know, families usually use, because this is in my case a family thing. So you got like 20 people in a group message, and every once in a while someone will share a picture of their child or their pet or an announcement. And often that's great at first, and then there's like this cascade of, oh, that's cute, and other similar responses that goes on seemingly forever, and your phone turns into a massage implement. It's maddening. And the best recourse that most platforms offer you is that you can mute that group of people. You can say, you know what, I don't want to get notifications from this for, let's see, the options Signal offers are half an hour, 8 hours, a day, and a year, because, you know, that's a linear sequence of logical steps. But muting that group of people risks that someone's going to post something else that actually matters. And this has bitten me a few times when I have muted a conversation that was exploding with things that I didn't care about. And then that group of people who I do care about posted something else, and I did want to see it. I just wasn't notified. So it's frustrating that your only option really is to control whether or not you're notified by who is participating and not what they're talking about. So I think the way we do chat has some problems. Subject matter changes and evolves, and the linear format that we use doesn't accommodate that very well. It creates lots of situations where it's difficult to tell what you're responding to unless you quote it, which is an annoying amount of work. And there's a fair amount of noise that can be difficult to filter. But I think that if we change the structure that we use to represent chat, a lot of these problems can actually be addressed in a satisfying way. So let's make chat a tree. Every message is one of two things. You're either responding to messages that already exists, or you're talking about something new. And I think that if you think about a conversation you've had, even, you know, in person out loud, that is true. You either walk up to someone and you say hello, and that's the first thing you've said, you know, you're beginning a conversation, or you're responding to something they've said. And in a group context, you know, I might say something, and the three other people who are with me might respond to that, but you don't always respond to the last thing someone said. Right? That's not really how it works. We are constantly saying, hey, you know, let's go back to the thing you said a minute ago. And that kind of thing is really organic when we do it out loud, but really frustrating and difficult when we do it in text. So on the left here, and I apologize if this is difficult to read. It was a challenge to scale, but on the left we have a conversation that might occur in a workplace around getting code reviewed. And if you look at it linearly, it can actually be pretty confusing. Hey, can I get some eyes on my pull request? Some coworkers, did you squash your commits? Someone else says, looking. I did. I'd love your feedback. And then that's not always necessary, which seems like a total non sequitur. And yes, this exact kind of conversation happens in front of me every day in Slack. This exact one is fictional, but I promise, and it burns my soul each time. But on the right, you can see that the real structure of this conversation is pretty simple. Developer asks if they can get eyes on their PR, and two other teammates, one says they're going to look, and one asks a question, and those are interleaved. Then that developer says, yeah, I did squash the commits, and response to the other one, you know, I'm excited to get your feedback. And then their other teammate says, you know, squashing commits isn't always necessary. It becomes coherent if you have a way to understand it as a tree, a way to visualize it. So if we look back at our like plan a birthday example, I've just indented it, right? And this format is intuitive to us because Reddit and Facebook and all of these other platforms that support comments have adopted this forever. Because somewhere along the way we acknowledged, you know what, having like rich, meaningful dialogue is difficult linearly. And it makes much more sense to allow it to branch. And we just haven't closed the loop and brought that back to instant messaging. It's trivial to see that Jordan is responding to Jennifer if you have the tree structure. When you look at threads like in Slack and Mattermost, if chat is a tree, then a threading mechanism is no longer necessary. Users don't have to remember to thread because that is, you just respond to things. And there's no discoverability problem around threading because all messages are the same. There's no need to have a special user experience that tucks them away in an obscure corner of your UI. I admit that you can argue, well, what if everyone just makes new conversations every time they want to say something instead of responding? And that's fair, but I think that at least is addressable with, you know, UX. And the other example, getting a notification storm because of family and friends who are talking a lot. If you have the structural information to understand where one conversation ends and the next conversation begins, it becomes possible to do things like don't notify me about this conversation about my cousin's new dog. But if someone starts a different conversation, I do want those notifications. So I don't have to say, you know what, screw my family, they don't get to notify me things ever again. I can just say, I don't want to hear about this dog right now. That problem kind of evaporates. So what is Arbor? What am I here to tell you about? Arbor is an implementation of this idea. And I've been working on it in total for 2 years. But it's also free, libre, open source, pick your favorite software. It is a set of open standards and specifications for building chat as a tree. It's designed to be decentralizable because the constraints that exist within the system are cryptographically enforced. They're not enforced purely as a some server checks some permission bit. The data itself has these rules that math makes you follow. So I didn't know the self audience very well when I made my deck. So I wasn't sure whether I should dig into like what is a cryptographic hash and what is a cryptographic signature.
We've had some B-sides events at our conferences, so don't shy away from getting deep on the security side.
Well, that's kind of the thing, right? Is it seems probable that these are old hat. However, I'll give a brief overview just in case we have some audience members who might want it. A cryptographic hash is an operation you can perform on any piece of data to give you like a fingerprint of that data. It's easy to check if a piece of data matches that fingerprint, but it's very, very, very difficult to come up with some data that has a specific fingerprint. And that property is super important because it means that if I have two friends, Bob and Alice tells me, hey, I've got some important file and here's its fingerprint, and then Bob sends me what he claims is a copy of that file, I can do this hash operation myself check that the fingerprint matches, and have high confidence that it is in fact the same file. And I know that situation sounds ridiculous. Like, why would one friend tell me a hash? But this property ends up being super important in a minute, so don't lose track of it. Now, cryptographic signatures are a related idea, but not the same, where we have a public and private key, which are both just pieces of data with a special relationship. And we can use the private key to create a signature on a piece of data. It appends a little bit of metadata, and only the private key of the key pair is able to do that. But anyone with the public key can check whether that signature is valid. And that means that if you plaster your public key all over the internet, people can easily check that you, the person who knows the secret value of the private key, perform the signing operation. And again, like cryptographic hashes, it's extremely difficult to invert this process. It's extremely difficult to forge a cryptographic signature. And when I say extremely difficult, I really am talking about, if you just try to continuously, you would fail to do it before the heat death of the universe. So I apologize if that was too elementary. I can go deeper later. Arbor uses a data structure we call the forest to represent chat. And it's called the forest because it is more than one Merkle tree. Within this a Merkle tree is a tree where nodes reference each other using hashes. It's very similar to the data structure that Git uses to manage version history, but not identical, because Git is a directed acyclic graph. And I can talk at length about why that is the case later too, if you're interested. But the Merkle property means that when I have a node and it references another node, it references it using a hash of the other node's like binary content. And that gives us some really cool properties. There's three kinds of node. There are identities, which are essentially like user accounts and public keys. Well, they are a user account and they contain a public key. There are communities, which is just a place to talk. I think about them as analogous to Slack workspaces or like Discord servers. They're not quite a channel. They're bigger than that because they're intended to be about a group of people with some common goal, but not necessarily about a specific subject matter. And then there are replies, which are just things people say. And replies either are a reply to the community in which people are talking, or they're a reply to do some other reply. Every node that exists within Arbor is signed by some identity node, and every reference between the nodes is a hash because it's a Merkle tree. So as I said, the identity contains a public key and it's self-signed. And that's important because it means that we can prove you control the private key that corresponds to the public key. So I can't take Linus Torvalds' public key and create an Arbor identity for him because I don't have his private key. Communities are really simple. They're just a name. They're signed by whoever made them, and they serve as a logical root for a bunch of conversation trees. And replies have a parent, which is either a community or another reply. It has some contents. It has the hash of the identity node that created it, and it is signed by that identity node's public key. We also use the term conversation to describe the entire tree of nodes that starts with the first reply underneath the community. So when I post my interesting article hyperlink, then somebody, well, then every response to that, every opinion that falls as a reply underneath that, it's all one conversation. So in reality, that example we saw earlier looks a little bit more like this. The code review community has this dialogue going on, and each of these nodes is a response to some parent node. So they've embedded the hash of that parent node. And each node is created by some identity, some author. And so they have a like author relationship with these three identities. So why did we bother making this a Merkle tree? And this is where I think the really interesting properties of Arbor start to come out. We can acquire Arbor history from anywhere. Because every node is signed, every node refers to every other node by its hash. If I have a set of identities that I know are valid, I can acquire the history of an entire conversation from some unsecured FTP server, if that exists, right? If that's out there. And I can check the signatures and the hashes of that entire conversation structure and have really strong confidence that those people said those things, and when they said this, they meant to respond to that particular message over there. And this means that we can do some cool decentralized use cases, and this means that Arbor can operate in a offline first mode, because we can make updates to this tree. We can create new nodes without talking to anyone. I can reply to a message, sign it. Everything about that data is valid, but it doesn't have to leave my site. And then at my leisure, when I want, I can ship it to the rest of the community. So we can do this peer-to-peer via any medium. We have literally used a sync thing shared folder as an Arbor transport medium. It has like fairly high latency, but it totally works. As I said, we just need the set of identities in order to validate nodes. And we can acquire new identities and validate that they match the data. That doesn't mean that they like belong to the people they say they do. There's always kind of that gnarly problem in a public key infrastructure, but at the very least, you can validate internal consistency. You can also do some like cool federated deployments where groups of relays, which are what we call our server-side infrastructure, cooperate to host content in federations. So federation logically is a group of Arbor relays that have agreed to host some set of communities. And a really interesting thing we can do is that if one of the relays goes down, everyone in the community or in the communities that it was hosting can just switch to any relay they want. And that relay doesn't need the history, or doesn't need in advance to have any of the history of the community that they want to talk in. Relays are almost stateless. So when I connect to a relay and it's empty, and I say, hey, I want to talk in the Arbor development community, that relay is like, I don't know anything about that. But now it can pull it from me. It can slurp up the information that it needs to host that community and check all of the signatures, all of the hashes, and it's ready to go. So relays are like disposable, which is a property that we found to be really fun. You can also do some like centralized topologies. You could add your own custom authentication and make your relay network not talk to big organizations. But we're not doing this right now. It's just possible. You can also extend the protocol and data structure to do some interesting stuff. So there's a few other things that really frustrate me that Arbor tries to address. I want to be able to filter content pretty much however I want. Mechanisms like the fact that you can only look at one channel at a time, or that you have to see every message in a channel when you look at a channel, are a little bit arbitrary. And I think we can do better stuff. I'm really tired of people using group mentions, abusing their anycast powers in messaging platforms. So I think that control over that capability needs to be handled differently. Maybe it's not even granted by default. I want to have all of my chat history when I'm offline. I want my chat history to keep working for me and be a source even when the server infrastructure that created it is gone. And I want to be able to look at more than one channel, community, whatever, at the same time. I understand that for many reasons that might be confusing, and I understand why that's not like a default experience. But in Slack, which I have to use for work, there are many times when I need to see different channels in completely different workspaces simultaneously, and it's a nightmare. And just the fact that it's not possible is maddening. So I think it's about time I showed you Arbor. I didn't think about the fact that the text is going to be a little small. I am going to switch and just share that window. Except, where are the Zoom controls? There we go. Okay. So, first of all, this is a completely unconfigured Arbor client. The client's name is Sprig. That's what we're calling this application. And you have to understand that because your chat is a Merkle tree, any message you send can't be deleted. Not only do you have no control over whether anyone else has copies of it, but deleting a message breaks the Merkle tree. Messages also can't be edited right now, but that isn't a fundamental constraint. You can achieve the aesthetic of editing a message without actually changing the node. You can just kind of ship a patch to the node into the tree. So we acknowledge that we understand that, and then we'll connect to our dev relay at arbor.chat port 7117. And here we go. There is an Arbor dev community hosted here. Before we go look at that, let's create an account. We'll call this self-demo. So we have just generated a new key pair and associated it with the name self-demo. Let's jump into the communities. So here we have a list of messages and a number of Arbor contributors saying hi to y'all. And it looks pretty much like any chat platform. It's just like a linear sequence of messages. Boring. What was I talking about? Well, let's click on something. So when you select a message in Arbor, the message you select is brought out in like a light color. And then we can see its ancestry. So facts is a response to I know right, which is a response to the new client color scheme as these hills sing. I think there are some really interesting things we said earlier today. Yeah. All right. So Here we have a message that is involved in a very long conversation and several screens, and there's a lot of intervening content. But first of all, I want to point out that it's really easy to tell what is and is not relevant to the message that I just selected. But also we can filter the conversation that we can see to remove all of the intervening messages. So now we're just seeing content relevant to the message that we had selected. And then, when we grok what's going on, we can turn that off. So creating messages works pretty simply. If you want to start a new conversation, that's this plus button. And we can say, hello from self. And maybe the Arbor peeps that are online right now will grace us with a response. We'll see. To respond to a message, whenever you select a message, there's a inline reply button that is spawned. So we can respond to Omelette here. So you'll notice that this message here is not being highlighted right now. It is not within our ancestry because our ancestor is, this brand new conversation. And these are our direct descendants. This is a sibling. Well, this is a sibling. It is a response to hello from self, but not a child of this. We're still experimenting with how to visualize sibling relationships because they're a little bit more complicated. And we already have a selfer in here. Wow, that is a self-starter right there. So yeah, this is Arbor. In all of its glory. This interface has existed for maybe 2 months. It's relatively new. We owe the beautiful color scheme to an Arbor contributor with a much better sense of aesthetics than myself. Her name is Elizabeth, and she's awesome. And yeah, I think I've shown you the core capabilities there, so we'll switch back to the slide deck. Switch back to my desktop. Okay. So Arbor's made of a few pieces. There's the forest, which is the data structure that models the chat. There's Sprout, which is the protocol that we created for exchanging updates to that data structure. We have implementations of those as libraries in Go. There's a relay server implemented in Go on top of Sprout. And then we have a terminal client called Wisteria and Sprig, which is what I just showed you. Sprig runs cross-platform. It'll run on a Mac, Windows, Linux, BSD, and it'll run on mobile devices. It runs on Android. It can run on iOS, but because Apple things, it is not currently possible for you to put it on your device unless you're a registered Apple developer and you build it yourself. We're working on that. More soon. So we have a few things that we're working toward right now, getting it up on F-Droid and getting it into Apple's test flight program so that iOS users can actually try it. Some UX refinements. It's a young client, and it's missing some integrations with like the platform that you might expect. We're working on enabling, real-time is so-and-so online or offline information. And then longer term, we're sinking our teeth into a number of other challenges. I think that channels are kind of artificially restricting, and we could do something cooler. Like, why can a message only be in one channel? When I think conversation naturally changes subject matter as it progresses. We might start off talking about Linux, and then someone brings up Plan 9 or BSD. And if we had channels for these subject matter and the Plan 9 and BSD people weren't in the Linux channel, they would never see that. They would never get to participate. But instead, if, and this is hypothetical, we've not attempted to implement this, if we use something like a hashtag that said, you know, I'm talking about Linux, and then someone's like, but that's kind of like, you know, OpenBSD, whatever. And then the OpenBSD people who have like already expressed in their client their interest in the OpenBSD tag, suddenly their client's like, hey, there is a conversation happening that you should take a look at. I think we could do some really cool stuff there. Because every identity is already a public key, we can do end-to-end encrypted messaging. It's not a thing right now. Our current focus is on enabling like open collaboration, like you might have for an open source project. So the data is not encrypted because that is not helpful for that use case. We think maybe you could do some really cool stuff with code review, like inside of Arbor. Set review, and I think I have some ideas there. And then notifications are a recurring theme in this presentation, I'm aware, but I think that we can do better than the state of the art in terms of allowing you to express the policy with which you want to receive notifications. Yeah, there's a lot there. If you're interested, you're welcome to join Arbor and introduce yourself. At least somebody already has. Appreciate that. We get together every 2 weeks on Thursday nights, and you're welcome to come. It's a chance for us to talk about what we've been doing over the last 2 weeks, to answer people's questions and gather feedback on development builds. If you're a developer and you're interested in contributing, you can contribute on SourceHut or GitHub. You can report problems or UX issues that you find. We have a mailing list. There's some patches there. There's some announcements there. And if you want, you could consider sponsoring me through GitHub sponsors or LibrePay to help me cover the rising cost of building and running this technology. I keep discovering new things that we need to pay for in order to let people use our tool in a low friction way. Every little bit would help. Yeah, so real quick, before I open the floor to questions, there's a few things that I wanted to express my gratitude for, because Arbor would be in a very different place without them. The first one is Geo. This is the technology that lets Sprig run on so many platforms so painlessly. It's a really cool GUI toolkit that runs on mobile, runs on desktop. There is not a single line of platform-specific code in the Sprig project right now. That's going to have to change as we integrate more deeply with certain feature sets, but it's been amazing how portable that code base has been. We host our stuff primarily on SourceHut. SourceHut is a GitHub, GitLab analog, but founded on some really compelling ideas around making open source and free software sustainable. And I would highly encourage you to check that out. And finally, Arbor itself takes advantage of a lot of services hosted on NixNet, which is a collection of free software services that are then hosted for free that you can go and take advantage of. My presentation right now is hosted on NixNet's deployment of CodeEMD. It's a really amazing platform. So you can get these slides here, either at the link or that that QR code is the same. I would love to take your questions.
So what we'll do for questions, Chris, is if people want to call in, they can call at 855-450-6624. That number again, 1-855-450-6624. You can ask them in the chat room, and I will read it to Chris. A couple of people have asked some questions in the chat rooms already. CR48 starts with, so once a message is sent, it cannot be deleted or altered. Did I understand that correctly? And I guess I'll append on to that. Is that designed to be the end goal, or are you looking at the ability to edit messages down the road?
Yeah, so that's a really good question, and there's more than one answer. In its current state, that is completely correct. In the longer term, there's kind of two roads available. The first one is that you'll be able to send a special kind of reply message that is like a patch edit to its parent. It'll only be valid if they're created by the same identity, but you'll be able to say, hey, actually, I made a typo or whatever in the parent message, so replace its content visually with this. But the parent, like the original content still exists within the data. Chat clients just won't display it anymore. As for like completely destroying or removing the content of messages, that's not possible if the content of the message lives inside the Merkle tree. However, we could easily kind of expand to enabling the Merkle tree content to be a like URL to the real content, such that that can resolve when you post your message, your client fetches the real message content over whatever protocol you choose to use. But later, if you want to delete that message, you can delete that content wherever it's hosted, however it's hosted, and your client can handle this for you, such that it is deleted and gone except for the people who've already seen it. So that's kind of the longer term answer for message deletion.
1-855-450-6624. That's 1-855-450-6624. You are on with Chris Waldon. Go ahead.
Hey, Chris, this is Thomas. My question is, could this almost be used as a mini transactional system, like something like a mini blockchain? Because it looks like the transactions are non-removable. And so I'd be curious. It'd be an interesting way to sort of have it's kind of a weird concept. But.
So I guess what application are you thinking of? You're calling it transactional, and that's true in that these nodes are created and they either exist or they don't. But do you have like a use case?
Well, I was wondering. Well, I was thinking if, say, you had an app store or something and you wanted to find out who paid for something, and you could use the Merkle tree with those, the node hashes almost as a verification of purchase.
I think that particular use case is probably more within the realm of the blockchain space than.
Okay, yeah, I was just curious because blockchain is expensive. That's all. I just was curious.
Well, yeah. There are other ways of using Merkle data structures to capture that kind of information. And I think that blockchains are not the only answer. I don't think that Arbor is pretty focused on communications. So I'm not sure that it's the right answer either, but you can do some really cool stuff that doesn't require everyone to have a copy of everything, but still takes advantage of Merkle properties and signatures to validate authenticity. I think that use case is very real and very tractable. Yeah.
Thank you.
No problem. Thank you.
Appreciate your call. 1-855-450-6624. That's 1-855-450-6624. Chris, I will ask, how is it possible to display the chat in the tree form like your very first slide, or is that just a conceptual drawing?
So that is a conceptual drawing right now. I would love to get out there and hack around with some like, OpenGL to really make that happen right in front of you. But the truth is that if your chat is actually spreading horizontally as a tree in front of your eyes, scrolling becomes a problem. Like, how do you know when new messages appear and they're not above you or below you? They appeared in a branch that's like in the virtual space of the graph, a mile to your left. How do we express that? How do we make that make sense? And I think that's an interesting challenge. But I would love to have Arbor Explorer that does that. And it just has not hit the point in the priority list where it's been implemented.
Have you come up on any limitations in terms of scale of messages, scale of people, volume of messages?
I'm confident that we will, but not yet. Because we're hashing and validating signatures, that has a fundamental overhead that's greater than, sending JSON blobs around where all we have to do is parse the JSON. And I'm like, we're not going to be able to get around that. But at the same time, unlike other systems where you have to have like a central source of truth about the conversation, in Arbor, really interesting stuff can happen. Like if we had two different relays that were hosting the same community and two different like conversations were occurring, or, at one point those relays were connected. And so they had a conversation that was happening and then they got disconnected, the network partitioned. Then both relays could continue hosting that conversation for their respective connected parties. And at any point later on, you can merge those two Merkle trees because Merkle trees are conflict resistant. Like, I'm not gonna accidentally generate a hash collision on one of those relays. And so we solve the CAP theorem by completely giving up on partition resistance because we don't need it. And that means that we can scale in an interesting and different way by just having a bunch of different relays that talk to each other.
Yes, I regret in particular that you could not present itself in real life because you had several good jokes in your slide deck. And it's terrible when a good joke hits no audience to laugh at.
EUCJC21 in the chat room says, question, is there a feature in the upcoming roadmap for file attachments? Is that something you guys have looked at all?
Yeah, so Arbor itself is pretty focused on the let's send text use case. However, that is something we're thinking about. And what I would really like is to achieve really excellent integration with protocols that are specialized for transferring files, right? So your Arbor client should know how to speak IPFS or torrent or FTP or whatever your particular transport of choice is, and the experience of that should be more or less transparent. That's an ambitious goal, but it's something that I think we will need. You need to be able to do that kind of thing. It's very useful. Not there, but yeah, we're looking at it. And if you're interested in figuring out how that should work, there's all those ways you can get in touch.
Amalith in the chat room asks, he says, ask him to mention the original client. What is the original client? What is that about?
Oh boy. So Amalith is the host of, the power behind NixNet, among other things.
Okay.
He's one of our community. The original client did attempt to visualize the tree, but it was a terminal client, and you could only see one branch at a time linearly. So you would get this view where you had messages flowing down the screen vertically, and then you'd have little indicators next to a message if there was an adjacent message to it, if it had siblings.
Mm-hmm.
And so you could scroll your cursor down to a message and then like scroll sideways to switch to that branch. And it worked, but it was impossible to understand when a new message came in, where was it relative to where you were. So I abandoned that approach.
Again,
I was going to say, I mentioned at the beginning, I've been working on this for 2 years, but I haven't been working on this Arbor for 2 years. 2 years and change ago, I was like, chat should really be a tree. And then I made like this garbage JSON-based protocol that just captured chat as a tree. That's all it did. There were no Merkle things. There was no cryptography. And I built some clients and some people got involved and played with it. And at the end, we concluded, this is actually pretty cool. We like this. We think that having the tree structure does help us understand it. It eases some cognitive load that we have always had when we're reading chat, and we've never really realized that we're having to construct this tree all the time until it started happening for us. But we all knew that implementation was garbage. So a year ago, we started over, and that time we were like, let's do this right. And that's why it's a signed Merkle tree now. And it took a long time to get some of the details in there working well. And yeah, so this implementation is not like maybe a year old. And this client, as I said, is very new.
What was your biggest challenge in implementation? I presume a lot of this, based on your GUI toolkit, was in Golang.
Yes, the current implementation is all Go.
So as a Go programmer, I guess a side question related to your biggest implementation challenge, and it's a dirty question for a Go programmer.
Oh boy.
How many GitHub imports are in your code?
It's really light. Yeah, so here is Sprig, right? So the client we were looking at. My go.mod is 3 things that I wrote, which have a very light dependency footprint, a few of the extended standard library imports for cryptography and other necessary things, and Geo. And so I know that because you're a gopher, you're going to ask to see the sum file. And let's see, it's 47 lines. Most of it is like redundant copies of the extended standard library required by my transitive dependencies. So if we ignore that, there's some OpenGL stuff that Go requires. There's file system notifications. Proton Mail's fork of the cryptography stuff, because their GPG or OpenPGP implementation has some extra features. Some X stuff, and my stuff. Oh, and a different GL related thing. But it's as light as I can make it, and I intend to keep it that way. I audit these things before I depend on them, which takes a lot of time. So I don't want them to be that. I don't want that many of them.
Chris, a question in the chat room from PyCrash. PyCrash asks, how about moderation? I would love to kick people from a community or delete troll messages. Is that a possibility?
Yeah, so we've been thinking a lot about moderation, and I think it's totally doable. Like the most naive solution, which is not yet implemented, but it's something on the near horizon, I think, is let's say that you're the person who created an identity. You're the identity that created a community. Every client can tell you made this community. And so we could start off by saying, yeah, that grants you moderation power within this community. So you can reply to a message with like a special metadata tag in your reply that says, you know what, this shouldn't be displayed. And that gives the people who are viewing that community a choice. It does not hide it. It instead says, hey, this has been flagged by the person who made this community as, off topic or whatever moderation reason. And then it says, do you agree, do you want to accept this person's moderator authority? And you can say yes or no, or we can craft a more granular thing. Like you can say, yeah, I'll accept their stuff for whether it's not something on topic. I won't accept their moderation authority for other axes of thing.
Mm-hmm.
Because at the end of the day, your chat history is yours and your experience is yours. And I think that moderation's important, but censorship is a problem. And you should have control over your experience of that. And so as we grow, we're going to have to expand from having one moderator to being able to delegate that authority. And I have some ideas about how to construct that system as part of the Merkle tree, but that might not fit in the time we have. So if you're interested in that axis of things, hit us up in Arbor or on the mailing list or in an issue, and I'm happy to dig into it with you.
The Linux Ninja asks in the chat room, how about access control, an idea of ownership of a channel, or how is the transport encrypted, expiration of messages, default colorization, all of those options? How is the configuration, I guess is probably a way to summarize that question. How is the configuration of Arbor done?
So insofar as it is possible, everything that can lives inside of the Merkle tree. But the Merkle tree is, or the forest, right, is agnostic of how you visualize it. It's going to tell you things like these nodes have this relationship, or this node is an edit to that node and should not be displayed. Or one thing that's half implemented right now is this node expires in or at some particular point in time. And that gives the client the option of deleting it. Again, we can't actually make somebody's chat client do anything. I think that's the greatest fallacy of, all of the disappearing message solutions, is that at the end of the day, if their chat client's open source, you can't control whether or not that message is gone. And I don't want to lie to users and say, yeah, that message is totally going to be deleted, because I can't ensure that. I don't have that. But we will have the ability to mark a message or a reply node as irrelevant after a certain point in time. And so that's on the roadmap. So there was some transport level encryption stuff. I mean, we do sprout over TLS, but right now, and again, this is just for the present, all conversation within Arbor does not use access control and is publicly visible. Right now, it's effectively like Twitter, except not many people know about it. But that's not a permanent thing. We'll be able to construct communities that are closed and have both policy-based, hey, don't let users subscribe to this community unless they're either on this list or signed by this key or whatever policy we decide to implement. And so you'll be able to stop people from connecting to a relay that hosts a private community. And then because we have public keys for all the participants, we can also do things like establish private spaces where all the messages are encrypted with a shared secret that's been encrypted for each participant using their public key. So we'll be able to create those more private spaces, but they don't exist right now. We're working on it.
Understood. Chris, thank you so much for taking the time to be here with us. We really appreciate it.